What's up, everyone? This is LeetCode 283, move zeros. So we're given an integer array nums, and we have to move all the zeros to the end of the array while maintaining the relative order of the non-zero elements. So, right, look at this example, and then look at the output, right? The zeros are at the end, and all the non-zeros are at the left side in relative order, right? 1, 3, 12, 1, 3, 12, right? So the issue with this problem is if you traverse this, right, linearly, you don't know where you have to swap, right? For example, let's say you want to handle the zeros, right? Where do you know, how do you know where to put the zeros? Because how do you know there's not a zero here or here, right? Likewise, let's say you want to handle it by using the non-zeros. How do you know where to put this one? To put it in the first index, or maybe this one's over here. How do you know if you should put in the first index or the second, or the 0th index, or the first index, or the second, or whatever, right? So one pointer is not a helpful way to handle this problem, but 2 pointers can be, okay? And I'll show you an illustration of how we're going to do that. And also, right, we're considering this follow-up in terms of how we're coding up our solution, is we're going to minimize the total number of operations, okay? Which is why you don't want to do O of n, because obviously, like, you don't want to go through completely linearly, or not linearly, but you don't want to have like an overly complicated solution because it's asking you to minimize the total number of operations, right? So this is how we would do it with a 2-pointer approach, okay? We're going to have a left pointer and a right pointer at the start, right? And we're going to use the right pointer to traverse, okay? And so this would be our right pointer, right? And they're both going to start at the 0th index, right? And when we encounter a number that is not non-zero, we're going to swap it with a left pointer, okay? That's how we keep the relative order, okay? So, and the reason we would never swap, let's say this is a 1, the reason we would never swap with another non-zero is because when we swap a non-zero with a non-zero, or sorry, every time we do a swap, meaning every time we encounter a non-zero, we move the left pointer over, right? So for example, let's say the starting element was, right pointers here. Let's say the starting element was 1, right? The right pointer is pointing at a non-zero number, 1. So we would swap the left and the right. It would obviously, we wouldn't swap anything technically because, I mean, can't swap. The left pointer and the right pointer are not swapping elements if they point to the same thing, right? Obviously. But technically we would quote unquote do a swap, and we would move the left pointer over as well, right? And obviously we could not swap anything here with anything here if that was the case. So rest assured that if this starting element was not 0, we would not run into problems with the solution. Okay? But anyways, this is the example 1, right? When r was at the starting index here, right, this is 0, so we don't have to swap anything, so we move the right pointer here, okay? So the right pointer's here, we encounter a non-zero element, right? And so we're going to have swap the left point, we're going to swap the elements where the left pointer is and the right pointer is, okay? So for example, this 0 becomes a 1, this 1 becomes a 0. We did a swap, right? So now is the time where we move these pointers over. So the left pointer is here and the right pointer is here. Okay. Is this a non-zero element? No, it's 0. So let's keep moving along. Okay. This is a non-zero, right? Because it's 3. It's a non-zero. So let's swap this with whatever is at the left pointer, okay? So we would swap this 3 with the 0. So the 0 becomes a 3 and this 3 becomes a 0. Okay. Now our left pointer is going to move over, right? And that's a terrible L. And our right pointer is going to move over as well. Okay, our right pointer points at a non-zero, 12. So let's do the swap again. So this would be 12. This would be 0. Okay. Obviously, we would move the pointer. We would move this left pointer over and this right pointer as well. But obviously, when we move the right pointer, we're out of bounds, right? There's nothing to check here. I didn't mean to put a 1 there. I meant to put, there's nothing to check here. We're out of bounds, right? So we would basically be done with the problem. And we would get 1, 3, 12, 0, 0. Now, if we go back, that's what we should expect, right? 1, 3, 12, 0, 0. Nice. Now, I want to go through a different example, right? What if we had something like, let's say 302, right? So the left pointer is here and the right pointer is here, right? Okay. Technically, this is non-zero, right? So we would technically swap the left and the right pointers of the value. But of course, they're pointing to the same place, so this 3 wouldn't go anywhere. So in this instance, technically, we would move the left pointer and the right pointer over by 1, right? And now here, for example, right, what would we do? This is 0, so the right pointer has to get moved, but not the left pointer, because we didn't do any swapping. Now we encounter a non-zero, right? So we would have to actually do the swapping. We would get 2, and here we would get 0. Let me do a different color. So our final output would look like this: 3, 2, 0. So you see how we still move the 0 all the way to the end here? Okay, I'm just showing you like weird edge cases like this just to understand how our algorithm works, okay? Because this starting value is non-zero. So when the left pointer is pointing here and so is the right pointer, technically we're still doing a swap. So the left pointer is actually going to get moved, right? And as you can see, that our algorithm works fine if we are doing it that way, because we still ended up moving the 0 to the end here. Because if we didn't do that, right, I'm going to show you why we have to do it like that, right? Right? Because even though this 3 and this left pointer and this right pointer, the left and the right pointer point to the same place. Let's say even though we're doing the swap, it's the same value, right? We don't have to move the left pointer, right? Well, if we did that though, we would have a problem, right? Because, okay, we have a 0 here. That's non-zero. Let's move the right pointer over. Okay, now we have a non-zero 2. Okay, let's swap this 2. Let's swap this 3. Okay, but you see we didn't move the 0 all the way over here, right? We didn't move the 0 to here, so this solution would not work. Not to mention, we did not keep the relative order, right? That's why when we have pointers pointing to the same place, technically we're still doing a swap and we still have to move this left pointer over as well, okay? Okay, so just be mindful of that, and that's how we kind of handle problems like that where, you know, the starting index is actually a non-zero number. Okay, so let's set the left pointer to 0, right? Or int r, we'll just call it right. Right, we're gonna say right plus plus, right? So if nums of right is not 0, then we need to do a swap, right? So let's store the left in a temp variable. Int temp nums of left, right? Nums of left equal to nums of right. Nums of right. That's the temp. And of course, we have to move the left pointer over, right? Once we actually do that swapping. Now, regardless if we do a swap or not, the right pointer is going to keep moving forward, right? This is a for loop, so we don't actually have to manually move the right pointer over. If it was a while loop, we would, but right, we're in a for loop, so the right pointer is going to keep doing that naturally because we're in a for loop. So yeah, that should be fine. And again, we're just moving this, we're just modifying this array in place. So we don't need to return anything. Okay. We're not making a copy of the array. We're not doing anything. So we don't need to return anything. We're just modifying it in place. So yeah, that's the problem. I hope this helped. And this video is a little bit longer, but I just want to make sure I'm very thorough in my explanation. I probably could have made this a little bit shorter, but I just want to be thorough. But anyways, I hope this helped, and I'll see you in the next one.